Welcome to a new episode of DevSecOps Talks with me, Matthias, and
Paulina and Paul again.
Paul again.
Yeah, I feel like a regular. I feel like I'm like a host these days. I've been on so often. Thanks so much for having me back.
But we were not finished with you last time, right? We talked about the project Swamp, right, and what that can do. But it's also like this interesting thing when you were a larger group of developer, and now you're like shrunk it down a little bit.
Yeah, so it's super interesting, right? Unfortunately, like there's a lot of I'll call something out first before like we continue on about the coolness of what can happen. We're in a bit of a juxtaposition at this moment in time in the industry. There's a lot of companies that are starting to not know what the future holds for their teams and the industry and the software. And we saw just last week that Blocks cut about 40% of their team based on the fact of unknown concerns about like what AI brings and things. So there's a real fear at this moment in time about what this actually brings into the industry.
Yeah.
System initiative, we didn't actually get rid of people because of AI. Like AI was actually a secondary thing that we picked up. And I want to be like super clear about that. When we like made the decision that we had to shrink the company to like rethink of what it was, of what our product was, we didn't even know what it was we were going to build, let alone how we would build it. Okay. It just so happened that when we started like putting together some thoughts and some prototypes and then we could see that what AI brought us. But it's really important that we're at this real crazy crossroads in the industry. And
yeah, but can you like maybe not everybody's following on it, but something happened some time ago, right? That really changed, right? Because we had ChatGPT and some like Copilot, and we had that we were working with it, and but what happened here?
So around like anybody who tried AI this time last year, okay, they were like, oh my God, this is either the best thing ever or the code or the systems that it produced was absolute garbage. Okay. Yeah. The models were just not as good as they actually are now. Around November, like October, November time, the models got really good. Like really, really good. Sonnet, really incredible. Okay. But there was also a big change around that time that we sort of realized that Gen AI, okay, yeah. And Gen, like it's, let's call it the difference here. Gen AI is like when you just like give an AI agent a specification and expect it to one shot like what it does and what it generates, and you take that one shot and that generate and you sort of like walk away with that and use it, right? Yeah. But we sort of like realized that agentic AI, where we interact with the AI agent more as a collaborator, as a pair programmer, as somebody on our team, like we realized in the industry that we got really good results, like especially combine that with the models and the reasoning. So you brought the human in the loop.
But what do you, I mean, we talk about really good results, right? Can you give an example? Because people like, it's hard to tell, right, until you used it and it does stuff that it just blows your mind, right? So,
yeah.
So what was it for you?
Okay, so for me, like in the old system initiative project, we started building a CLI. Okay, our CLI was written in Deno, okay, which is like, a JavaScript style system that uses TypeScript. And when we started like testing it, like because it was so well trained, like the models had a lot of information about the libraries, about the ecosystem, we find that it actually started writing like decent TypeScript, right? And I say decent, it's not the most beautiful. You'll not look at it and go, oh my God, that's the most well architected code that you've ever seen, because it doesn't understand any of your architecture patterns. It's just going to blurt out raw code. But then when we started to interact with it and give it some idea of patterns, some practices, some other code that it needed to follow, it started being able to produce the code in a way that was coherent with your code base. So it was starting to then realize like what it needed to follow, the conventions that it needed to use. Maybe it didn't do things like, extract methods and reuse methods. But in an AI world, maybe that's not as important, right? Because we used to do that in software for taste, because when we wrote code, we wanted other people to be able to read it. They needed to be able to understand it. They need to be able to reuse it. But in an AI world, if the agent is the one that's actually using it, if you can give it the code in the easiest path possible, then it was actually able to like give it some very interesting results. So when we at System Initiative started realizing that, like I got really geeky at the end of the year before the Christmas period, before the holiday period. I had like my terminal open. I had 6 Claude codes going at once, building like 6 different small features at a time, feeding it bug reports, feeding it data. And every time, like I was honestly like delighted with the results that it gave me because I wasn't one-shotting it. I was always continually interacting with it, testing it. Are you sure this is the right plan? What about thinking about this? What about thinking of that constraint? And it was always able to then reason and give me the right results based on it.
So you like started 6 terminals, 6 different like branches of the same app, and just like do that. This is
using Git worktrees basically, right?
Yeah.
And because it's using Git worktrees, like they're all like separate from each other. They're all able to like interact, and then you can use pull requests in order to bring it. So I use this same model today. I actually like have a Mac Mini, and I'm able to use Tailscale, and I have like longer running tasks that sit on a Mac Mini and my Tailscale, and then I have like my shorter tasks that are like happen on my laptop. But the world has like it's completely changed since those models and since this new reasoning and since the way it came into play. And of course, plan mode became such a huge thing as well, right?
And what is that then? You have to explain
like
it.
Plan mode is, if you don't use it in Claude Code, you absolutely should, right? So plan mode basically says, I'm going to create you a plan, a detailed breakdown of what I'm actually going to do and the reasoning about why I'm going to do it before I do it.
Yeah.
And that stops us from having the AI horror stories where it just goes off and deletes your database, or it just goes and rewrites an app into like whatever it needs to do. It's actually giving you the ability to reason and understand what it's going to do before you do it. Yeah. And that was a huge like move forward. Now, some of the tools are starting, like Claude Code, of course, was the first to support plans. Other tools are now starting to take advantage of that sort of plan mode. Yeah. Because they see it's such a very nice way to interact with an agent, and it's given like results across the board, not just with Claude, are starting to be very, very
cool.
It's a bit like Terraform. You have plan always before you're able to
similar
do it.
thing, right?
I mean, the same principle. Yeah,
exactly the same principle. You're right, and like there are people who don't read a Terraform plan in the same way as there are people who will not read the plan of an AI agent output, but that's then becomes a personal choice that you've ignored it and that you've not actually understood what it's going to do, in the same way as if you did this at, a Terraform plan and there's a big line in there in the middle that says, I'm going to delete a database, and you haven't read it. It's the same thing, if you know what I mean. So.
But this is like how it started, right? You're trying to do more. You're like, well, I can do like 6 tasks in the same time to the same repo, and instead of writing the code, you can just guide your juniors or your AI agents.
And like, there's a tax here you pay, right?
Yeah.
And I mean that. Okay, so as engineers, we've always like tried to single tasks so that we don't lose context. Context switching has a huge tax that goes on it.
Yeah.
If you can multitask now and you can like move around and you can command multiple agents at the same time, wonderful. If you're still a person that enjoys and has to work and focus on a single thing at a time, don't go that multi sort of agent route, because it'll be such a context switching killer, and it'll cause you to lose focus. Maybe you actually lose the focus of what it is you're trying to solve. You could get mixed up. So, it's just an adaptation of the style of how you work. And it's just that you're not writing the code. What you're actually doing at this point is you're commanding architecture and you're commanding design. And then you're just like enabling other people.
But how would you? What? Yeah,
also,
sorry.
I wanna go back before we go further to one point. The limit, because I also noticed that I also sometimes because I work with different customers. I have some who banned AI completely, and I have some who are AI. Let's put AI everywhere as fast as possible. Of course, if it's enterprise, it takes some time. So it's complete spectrum. And it's also, the content, or some who in the middle who allowed, for example, you can have, Copilot, but agent, forget about it.
Yeah.
Uh,
I actually read a really interesting anecdote recently, and like for you as a consultant, this may resonate a little bit. It said basically the first 1,000 lines of code that an agent reads will help determine its path forward in the future, right? So what that kind of means is if the first 1,000 lines of code is spaghetti, not well architected, is a bit like, has no guidelines and principles for it to follow, it's just going to continue creating like spaghetti on top of it.
Yeah.
But if you have a project that has a very well-centered, design principle and pattern that you can actually give to the agent to feed, it will actually be able to follow that. So, as you're interacting with some of these companies, large, small, some banning AI, some using it, like you'll begin to see some very interesting patterns of how it's actually adopted.
Yeah, exactly. It's a multiplier. If there is a good thing, you get a lot of good thing. If it's a shit, you're gonna get a lot of shit.
Absolutely.
And one thing,
but how good shit can you live with, right? Sometimes, I mean, I've seen a lot of things running in production that are just shit, right? But they bring in a shitload of money as well, right?
Yeah, as long as it's not public, there's some limit when.
Yeah, you have to think about like security constraints. You have to think about, constraints with regards to how your users' data is actually being like taken care of. So there's definitely things that like are important to think about. Like there's kind of 3 pillars to how we used to build software, right? So like there's architecture, okay? There's patterns, and then there's taste. Okay, when I say architecture, I mean like design patterns, DDD, CQRS, those types of things. When I like say patterns, I mean like, dry, don't repeat yourself. You're not going to need it. Keep it simple, those style of patterns and practices. And where we've kind of spent most of our time in the industry over the last sort of 10 years is in the taste. Okay, how do I arrange my Terraform modules? What is my naming conventions? How do I lay out my project? Okay, and we kind of had people who we laughed at for a long period of time in the industry. I'm incredibly guilty of this. System architects, right? People who we said, oh, they don't code, they just architect the system. We call them ivory tower architects, like, and all sorts of things. But if we think of it, right, those people spent the time in the architecture land. Okay, the rest of us spent more time like much lower down into the code and the taste and the principles. In an AI world, you actually need to step back up into the architecture land, because if you don't give it that architecture, then it's going to be really difficult. An AI agent doesn't care about naming conventions. Okay, it really doesn't. It's gonna try and follow them as much as possible, and it will 100% create methods of exactly the same like each time until you tell it refactor, use a central thing. So you have to be able to give it that detail. But architecture is becoming incredibly important again as we move forward.
And I think at least what I'm seeing, we're going at least a bit away from specialties. Like you're becoming more like software person than we have DevOps, backend, frontend, something. Of course, it depends what you build and so on.
Totally agree. And it's actually going to be incredibly interesting on how we train junior engineers, like how people come on board, because we see a lot, especially in the DevOps ecosystem, the infrastructure ecosystem, where people come on board and they're like, I'm training on Terraform or I'm training on Kubernetes. And they just become syntax now, right? They just become specific versions of tools. In the world that we're working in, like maybe you need to know how they're put together and how they're used. But do you need to know how to write a Terraform module? Do you need to know how to like write a Pulumi provider? Do we need to know how to write? Going forward, there's a lot that's going to change. So teaching people actually principles and practices and going back to like the basics of engineering is going to become really important again, I think.
To be honest, I got asked recently by one girl to mentor her, and that's because she want to get into IT. I'm like, I had a bit an issue because I started before AI. And you learned I don't have IT education, I have engineering education. So I learned on the go all the stuff which you need to know. But I don't, you don't really learn with AI straight away how to do it. You can learn a bit when you start building the project. Okay, how do you do it on the small phase? How do you do it on the bigger phase, and so on? On the bigger project, like when it grows and so on, you need to know that it needs to get some refactoring. But at least, I have in my head, even from Terraform, if I go into front end, it needs to get some refactoring at some point because the scale changed. And how do you give this to a junior? I still didn't find a good answer for it, but it's an interesting question.
It's incredibly and this is, I gave a talk recently about this, and I basically said at the end of the talk, we are now in control of helping shape how this moves forward in the industry.
Yeah.
Okay. We're very lucky, right? We are very much on the innovation age of AI. Okay. And we're innovators and like early adopters of these technologies, especially in software. So we're actually the people who can help set these patterns and practices going forward. If we don't, and we sit back and wait for it to happen, somebody else is going to set them for us, right? So this is like what we're trying to do now with our projects. Please don't take it that I'm showing you that this is the best way and the only way that you can do it. This is our version and our thoughts. Okay. So firstly, we encode all of our design patterns and practices and the layout and the data layer as design documents in our system. Okay. So you can go to our repo. It's open source. Okay. And you can go into the design folder and you can read every part of the system and the breakdown of the design document.
What do you mean with design? Like databases, network?
Like actually like the design of the model layer. And when I call it the model layer, like the actual objects that get pushed around and how the objects are written, how they're what they're for. Like we go down into the most minute level. Then we have like design documents about how workflows are built, which is how you connect models, how you pass data around. Then we have design documents about how expression language works. So here's what works, here's what doesn't. And given that design document to the agent, like, is really important, okay? Because you're giving it like the intent of what the system needs to do and what it needs to hold. Yeah. Next thing we do is we actually like encode our architecture. Okay, we say it must be domain-driven design. Okay, and we load in the domain-driven design skill, which means that things are kept into domains and they're kept into infrastructure and they're kept into repositories and they're kept into output layers. And we actually basically tell it, hey, you need to keep very good separation between these layers to make sure that you're adherent to domain-driven design. So we're instructing it of how it has to build the software. Next, like off the back of that, like what we actually like build then is we tell it, small things around how it has to test it, what the code style is, what the TypeScript style is. We have strict mode, no any types. We want to use named exports. We want to make sure that everything passes check, lint, and formats. Everything has to follow the right license. You can't pull in a license because we're AGPL3. Yeah. V3, you can't pull in anything that doesn't adhere to that license. That's all encoded before it even goes off and reads the software. Okay, and then everything else is built down and broken down into skills. Okay, now skills is a new way of like being able to lazy load information to an AI agent. Okay, when it like is able to ask it a specific question or it needs to do a specific thing, it lazy loads skills that are actually found within the repository to help it understand like how it breaks it down, how it runs it, how it does it, how it builds it, and that's kind of how it's there. Then for us, everything is very strict specifications. Okay, so for example, a user comes to us and opens an issue in our repository. I need to support this. I need to support that. Okay, we take that issue, we push that through an AI agent. The AI agent actually decides if it's a legit issue or not, if it's actually a legit feature request or not. The response and the summary is immediately posted back to the issue. Okay, because that issue then is then used as context to feed in to the agent to help it understand the reasoning and the choices and the design it made. Okay. If it's a legit issue, we immediately go into plan mode. Right. Yeah. You said it's a legit issue. You said the issue is here. Let's go into plan mode.
Then you get the input from the user. Like, I want to have this feature. you read that, you kind of like, is this verified? And you put back like the spec, like this is, do you
Yes,
mean blah, blah,
that's
blah.
exactly it. The
And
user then can come back to us and say, that's kind of not how I feel it should work.
Yeah.
We'll replan it. We'll re-push it up. The user will then say, that looks good. And then we'll take the AI agent to be able to go and build it. Now, what's different in our world? Okay. Because this software is 100% written by AI agents, we do not accept pull requests. Okay. Now, the reason we do not accept pull requests, we love contributions.
Yeah. But,
okay. But in the AI world, we cannot control where that code is from or what that code is doing. We want to control the supply chain of the tool.
Yeah. And
because
that's
it's
not a problem,
really
right?
important.
It's just
exactly. It's really important that our AI agent has all of this knowledge that we feed it and all of this context that we feed it, and we want to control that supply chain.
Very interesting.
We've actually blocked. There is a new feature that was added like 2 weeks ago, 3 weeks ago to GitHub, where it's like you can turn off pull requests for external contributors. Okay. Before, what you would have had to do is write a GitHub action that if it came in and it's not a contributor, it auto closes it. But now you just turn it off, so they can't even like create one, which is excellent. But what we actually do in our contributing doc says, hey, if you have a design, if you have an issue, if you have a feature request, open an issue and we'll interactively walk through this and we'll design it together and we'll come back and do it. Now, we found that the level of issues that you can get from people are vary. Okay, people can give you very detailed issues, which are brilliant. People can give you not so detailed issues that are brilliant. So what we actually built into Swamp itself is we built a skill, which basically, if Swamp finds a bug in itself as a user is using it, it has the knowledge to understand that it can check out the version of the code that the binary is currently built against. It can analyze it, and then it can open it can open an issue with that detail and that breakdown. Okay, because again, like it's going to create a very detailed like bug report, like issue that we can feed it in. It's already going to know where the issue is, and it's incredibly intuitive to watch it work, right? And the level of issues that we're getting because of it is really high quality. Because the system is actually able to push that data and push that context back in. Now, when my AI agent then looks at it and goes, oh, there's a new bug. Yeah. I have all of that context exactly how I need to fix it. It's an incredibly easy fix. So, you can really begin to be able to like go through the different motions.
Okay, but you're not really using the AI agent in your terminal anymore. You're trying to move all this planning stuff from your 6 terminals up to GitHub issues.
Yeah, only when it's an external contribution.
Okay.
Okay, only when it's an external contribution. If it's a feature that we're working on internally, we'll try and publish plans just because it's great context for people to read and they can understand, what it is we're building and why we're building it. But a lot of it becomes changes to design docs and then having to use that design doc in order to drive changes.
Very interesting.
Now, the cool part of how this all comes together is pull requests. Okay. So we have an agent that writes the spec. We have an agent that writes the code. We are reviewing the spec with the agent. So when you push that back, you still got to review it, right? You have to. Yeah. So you use a different agent to review it. Okay. Because then it doesn't understand how it was written, why it was written. It looks at the code. Yeah. Now, I've even introduced a 4th agent. Okay, so we have a happy path agent, which looks at, it loads up the Claude, it loads up the skills, it makes sure that it adheres. Just like 3 days ago, like Monday actually, I introduced an adversarial agent. Okay, and I actually said, you are a grumpy DevOps engineer, and I want you to look at this code and actually, I want you to pull it apart. I want you to tell me why it's not going to work. I want you to look for the security injection points. I want to be able to see these different things. So like we have like Jekyll and Hyde on the pull request. And if the happy path comes back and says, this is looking good, this adheres to all your code standards, and the grumpy one comes back and said, yeah, but there's a big security vulnerability here, the pull request will not merge and we'll have to make the change and push it through. If the grumpy one comes back and says, yeah, this code is sound, it's like, it's not a big security risk, there's some tests that I would change in order to catch these things, then it would actually be good. It actually caught a path traversal bug this week. Okay, which was brilliant. And that's like, I was like, if I didn't see it, like it wasn't a, because it's a CLI that runs on people's machines.
Yeah.
So there's not a huge risk, but it proved the point that it was incredibly important to bring these adversarial agents.
I mean, so if we go back to the chain, right? You add your issue, you get a plan back, you said this is great plan, go and fix it. The AI agent works, commit a pull request back. You have one that you check, like you just look at the code, right? Like a regular code review, like, oh, this is good.
Yep.
And then you add your like grumpy one that just tears apart again, and then you get the summary that you as a human look at, and then perfect, just go.
And like all of that is written back as comments to the pull request. So you can follow the life cycle of when something passes, when something fails. Now we have a web app that runs as well. We've even encoded like accessibility guidelines that it has to check for, to make sure, and security vulnerabilities that it has to check for. What we can do at this moment in time in this era of ecosystem, not us at System Initiative, what we can do in the era right now is just mind blowing.
Yeah.
Like features we're able to turn around way faster. And it's not because we're just YOLOing it and vibe coding it and letting it go. It's because we're actually like, we know, as humans, we know what we want to build.
Yeah.
Right? We've always known what we want to build. But then it becomes the time of how we trade that off against other pieces of work, where it fits in the product plan, how we actually do it, how we build it, how we architect it. Typing was never a constraint for us. Typing is just slow, and like it's just the way it works, depending on the size of the feature. But it's all of the other pieces that go together that you can turn around way faster now, which means you can experiment more.
Yeah, but how many is at this stage? I mean, most people still think about it like AI making code, like some vibe coding stuff. It makes some application next to you as well, and then you have it running on Lovable or something. I mean, this is something else, right?
Yeah, it's completely
One comment to it, I think a lot of people still use, for example, get on this if they in software, they got on the first phase of it when they put it, in your IDE, Copilot or anything else, and they work with this versus with the agent.
Yeah, and I love Copilot. I mean, I love it. It was just like fixing if-else's, right? I like if it's like, do you mean? I'm like, yeah, I just tab that out. Don't have to type 20 lines.
Yeah, and you knew what you were going to type.
Yeah,
that's the thing. It's not taking away the fact that you didn't know it and it taught you how to do it. Sure, there's ways that you can do that, but you know what you're building.
Yeah.
All this does is, I think Paulina, you said it's a force multiplier. Yeah. You know what I mean? It is literally allows you to be able to move at a pace that we've never been able to move before. And in ops, like we're always busy people, right? Yeah. Ops people are incredibly busy people because we're kind of the engines that keep like the system running, right? And you always hear, I would love to be able to get back to do that. I just don't have time. I would love to be able to do it or refactor that and don't have time. I'd love to bring in a better tool to be able to do it. Now we can do it.
Yeah.
Now we actually can do it because we're in a situation where we can start to be able to put together these processes much faster than we used to.
You talked a lot about development. What about testing?
Oh, testing's my favorite part of this. Okay. Yeah. Like, so I developed, so we have many layers of tests, right? Super many layers of tests. Firstly, we have unit tests and integration tests, like all software has to have, right? Then we have user flow tests. Firstly, before I go that, we actually have architectural tests, okay? So there are such a thing in DDD where you can write contract tests, property tests, and architectural fitness tests that make sure that the domain doesn't leak. Okay, make sure that it follows the correct conventions and that the AI agent is actually doing the thing that you told it to do, right? So we have that layer of testing like at the lower level. Okay, we call that like the product level testing. But then we have a bunch of user level testing. Okay, now that sits in a different repo for none other than the fact of I don't want it to be influenced by how the code is written. I want it to be influenced and written separately because of how a user uses the system and it tests against compiled binaries. Okay, so it's like the user needs to be able to like create a repository. The user needs to be able to then extend the system. The user needs to be able to create a workflow. That workflow needs to be able to run this model, and it needs to be able to do this. If you give it the wrong input or you give it the wrong constraints, then it's going to error. Like actual like user story test, if you can kind of think of it like that, right? But then there's another level of testing as well. Okay, there's adversarial testing. Okay, the adversarial testing is like the super interesting part, because like how we actually put those together, we have multiple tiers of those adversarial tests. Okay, so like on the bottom level, what we have is security boundary tests. Okay, that's the path traversal. That's making sure that like, you know, you don't just like are able to like pull environment variables out of people's shells and read them back. And because we've seen horrible instances in the last like week where a bot was able to get an API key and it was actually able to delete all of Trivi's releases, and it was able to publish like a poisoned VS Code extension, right? We need to be able to test against that type of stuff. Level 2 then is state corruption. What happens if people just go and like mess around in the state layer? Like how does the system react? How does the system like go from there? Next layer is concurrency. Like what happens if there's multiple writes? What happens if there's lock failures? And then the last one, which is like most important for us, is resource exhaustion, right? So if you're running a workflow and like you have a workflow that somebody injects a standard out message that's 100 megabytes, and you want to make sure that the system's able to cope with that, right? So we have all of those tests running on our binary before it actually gets to the end user. So you have the lower level code test. Then when the binary is produced, the next level of user integration tests kick in, and then you have the adversarial test kick in on top. So, you know, if you are well disciplined on testing, then it's really good because you're actually able to put together like this setup. If you're not, like if you don't know what the product needs to do, then you're going to struggle to put together like the user level based test, and you're going to be in a bit of the Wild West. What this actually does for us is this prevents breaking changes for users as well, because we're actually able to flag changes before they even go out into the real world, because if it breaks a user flow, we can see it before a user even gets it.
And it's also, as I said before, it's a multiplier, right? So it's no reason now why they shouldn't be in a test, right?
Oh, absolutely. Like, absolutely. I mean, we were scraping the barrel before at coming up with reasons why there shouldn't be any tests. Now that just is eliminated completely.
No, because you don't do it, you just add in like, by the way, add test here.
Exactly. So like the bunch of lessons here, and there are a bunch of very good lessons, right?
Yeah.
So don't give mega prompts. Like don't just write like a random rebuild me Slack, okay? And expect that an AI agent is going to be able to do it. You would be so shocked at the amount of people who try this type of stuff. And then they're like, oh, AI is garbage because it wasn't able to do the task that I was able to give it. I mean, you gave it no context in any way, shape, or form. Like, right? Nextly, like, always give design docs, because if you give design docs and you give specification, it's going to produce you really good stuff. Okay? Don't skip straight to the code, right? Don't say, code me this method to do this, this, and this, because it's probably going to find a good way of doing it without actually you giving it any code. Small, that's the key. Small tasks at a time, right? Don't do these huge, like, project-wide rewrites with a single agent. You'll just never be able to deal with, like, what's happening.
It's going to be so much stuff as well. It's going to be...
They're losing context.
Yes. That's the new, like, restart your machine, right? AI agent, compact and conversation. And then never trust the first plan that it gives you. Never trust it. Like, honestly, always question it. And people at work laugh at me about this because I'm like, and they even see me type it. Are you sure this is the right plan? Are you sure this is the right implementation? Tell me as a 5-year-old why this is the right implementation. And it's like, oh, actually, that's a really good point. Maybe I need to make it like think like this. And it's like, are you able? Does this fulfill what the user needed you to do? And it's like, yeah. So, you know, that's like the key learnings here of what's actually happening. That combined with very good testing, and you honestly get really good results.
Cool.
Now, you can look at our repository and you'll look at some of the TypeScript and you're like, I wouldn't write the TypeScript like that. It doesn't matter for us,
Yeah.
honestly. And the reason it doesn't matter is we know that it does the job that the user needs.
Exactly.
It's well tested, and it follows good security principles, and it doesn't violate our domain boundary, which means that the actual syntax of the code itself can change 12 times a day. It doesn't really matter as long as it adheres to the product.
Yeah.
Do you put human in the loop before it goes live?
Always. Like
Where?
everywhere, every single stage. We're always looking at the plan output. We're looking at the implementation output. It's really like one of the things that we ask the agent after it implements something is give me a breakdown of the implementation versus the plan that you came up with. Find the areas that you said that you were going to do and you didn't. Tell me why you didn't do those. Tell me why they're not important. Every time we are questioning. So like, it's not me just logging into my laptop and then just letting things happen. What it is me continually interacting with code, with Claude Code, and like actually coming up with the right design for something. Before it even leaves my laptop, I am well sure that it is there. Somebody else can pick up the same plan, have a look at the same thing, and there's no issue. So we're continually interacting.
Yeah, but I'm talking also later in the process, because in the traditional way you have, locally we develop something, then it goes to the repo, it gets through tested, pipelines, goes to dev test, maybe pre-prod and production.
I see what
and
you mean.
usually,
yeah, I'm continually testing the binaries that it produces before they're actually published, like to the end user. Like we actually have those binary tests that I will always download something before it goes to stable. So the way our release pipeline goes is everything that gets pushed to main gets published as a release. I can download and play with that release. Only when it passes all of like the end user tests and the adversarial tests do we promote it to stable and an end user would get it. But it becomes kind of like a nightlies channel, and I can download any nightly that relates back to any code and have a look at exactly what it's doing and run the test that it actually needs. Play with it myself if something feels kind of funky, and then I can actually push it out to you.
Yeah. How important are the agent that are testing the code? I mean, you don't write any code today, right?
I write.
You don't do any tests. I mean, you tell it, you get the code, you can see the plan, like this is what it do, but you don't know. Yeah, as a developer, don't write it. But then you have other agents that look at the code and gives you summary of it, and then you have a multiple agent that look at the output from the agent and gives you a summary back, and that's more or less what you're looking at, right?
Yeah, exactly. So small, tightly knit job agents is how we do it, right? Like we don't have one massive agent that does everything and is aware of every piece of the system. We have our own dev loop agent that we run, but when it goes into CI or into like our deploy pipeline, we have specialized agents that try different pieces of it and like analyze different parts. And only when all of those agents actually act together and come up with the right understanding and the right checkboxes is actually when this gets released.
It's kind of, it's more or less like an integration survey. I mean, that's the same as you do when you commit to main before and you went over and you did all the tests and then you went to production. But it feels like you're kind of removing the step where you make it before, right?
Yeah, we're actually kind of going back to old user acceptance testing, right?
Yeah.
Remember like when Agile first came out and we had this huge sort of level of, we used to have QA engineers and those QA engineers used to run the test. We're kind of going back to that era now. Because if you don't have those end level tests that actually are user-based tests that exist in the user story test, the same way as a QA engineer would have done them, then it's going to be very difficult for you to have confidence in the actual like product or binary that comes out the other side. And you're kind of flying blind if it's going to work as expected, right? So, and this is what I'm saying is like we're truly at the forefront in the industry at this moment right now about putting these patterns and practices together. You speak to 5 people, they'll give you 5 different answers of how their practice and their pattern works. So we're starting to like figure out like how this comes together. And it's, for me, I think it's going to be less general patterns and practices, and it's going to be much more specialized per org. Like, you don't have to go and take the same patterns and practices that I do because your app is built differently. And because we can move faster building those patterns and practices and putting those principles in place, that's when we can start to be able to accelerate.
Yeah, but isn't that a good thing? I mean, now it's a lot of people saying like SaaS will start dying, right? You can replace your SaaS, but sometimes you have to adapt your work set after a certain tool. You want to have GitHub, and then you have to work in that sense. But now actually you can like, you know what? We can build our own ticketing system and matching exactly how we are working in the flow to tailorize it more or less. And I think, as you see, more tailorize what you actually want to do in your company, which much more benefits for it as well, because then you don't need to shove around as much. You can just go and make your product.
Do you think that people who have, okay, we have our IT background, you could go, if something go bananas, go to code and check it and fix it, yeah? But there is whole new movement of people who have nothing to do with coding, and they start using the agents, and they, one example in Poland recently, there is a centralized accounting system, and someone made a app to being able to upload receipts there. It went public, and all the data of their customers. So, simple stuff like this, and which we are very aware of, and people who don't have this experience, they're not aware of it.
Yeah.
This is why the fear, right, of people losing their jobs is honestly unfounded. Okay, and it's fear because they're worried about the future, what it brings. But those examples are exactly the reasons why software engineers, ops people won't lose their jobs, because you've built up a set of skills over the time that allows you to understand the good patterns, the good practices, the good principles. Without you guiding the AI agent to get there, then it is gonna make those mistakes, because it doesn't know the security boundary that you have to live in. It doesn't know the domain. It probably didn't know that it was a receipt server for like a centralized system in Poland that other people were going to use in the public, right? Because it probably wasn't fed that information, that it had to think about the security context and had to think about it. So that's why I actually think if you learn, as engineers, if we learn to use these tools really well, you're going to be such a force multiplier within your organization. Now, unfortunately, there will be people who will not want to work in this way, and they will not enjoy working in this way. And as organizations try to move in that direction, there is going to be this sort of button of heads that sort of allows, some people will end up leaving companies because of it, and based on what's happening. But I honestly believe that people who realize exactly what you said, that this is a force multiplier and that they're important and they can get stuff done faster, you become even more important to your company than you already are.
But also a question, who's responsible is it, right? Say that now you're just saying Lovable is here in Sweden, right? They're using that one. When you build an application for security, right? If I'm coming and don't have any knowledge about I just want to build my app, right? And they build it and it's unsecure and leak data. Who's the responsibility? Is it mine? They just tell the agent to build the app? Is it Lovable that make that kind of build the app unsecure in this way, right? It's I don't know where we're gonna end up. I mean, there's always gonna be the agent or letting people build unsecure applications.
Yeah, for sure. And there's a whole educational setup that has to happen here about skills and about bringing in, you start an app from scratch, it's a website, it's going to be public. You think immediately, you bring in the security skill, you bring in accessibility skill, you bring in this, and it's once you know this is going to be a public site, this has to be accessible. When I say accessible, it has to be good for people who have visual disabilities or whatever they need to be able to help them, or they need to be able to have text to speech and those types of pieces. Once you learn that you can bring those skills in, and that the system will help you build in the secure and the accessible way, especially for web apps and pieces like that, then you're actually be able to do it. So I think we're going to see a lot more specialized agents that are going to help people. I just don't think we're quite there yet. I think skills is a step towards that. And I think we're going to see over the next couple of months, it's going to be another set of incredible.
That's my next question. Next year, the same time, right?
It's going to be. I mean, we're exponential. Like we are honestly exponential at this moment in time. How fast the models are being trained and like the data that's coming out of them and the reasoning that's coming out of them is incredible. I'm going to skip the ethics of AI companies at this moment in time. We probably saw Anthropic versus OpenAI and these different things. I think there's going to be other things that'll happen. Like one thing that's really important to think about here as well is cost. Okay. AI
that was my next question. What's
AI
the cost
has
of all
an
of it?
Incredibly inherent cost of it. And if you're small and constrained and you can actually keep it like on track, you can keep the cost really low. When I say that, we have 5 people in an entire system initiative at this moment in time. We all have Claude Max Pro. Okay. Claude Max Pro is $200 per month. We do not exceed $200 per month. For a fully automated system that is doing code reviews and writing the code and creating the plans, we do not exceed developer cost of $200 per month on Claude Max Token. I know people from other companies, and I have seen the reports where people are spending $10,000, $11,000, $12,000 per month on Claude Code tokens, or not just Claude Code tokens, just on AI tokens in general. Because they're doing this vibe coding, like just telling it to go off and do everything, and it's trying to like read all this context, and that's the key, right? If you constrain it to tasks, those tasks are going to be nice and tight turnarounds and fast, and it understands the context of what it needs, and it's actually more efficient in cost than it is if you tell it to go and do the world. And that's always what we found in software, right? Even when we as engineers, we're building things. If you gave engineers really tight, defined like stories and tasks, it was more efficient to get it through the system than it was, hey, go and rebuild me this system. And they're like, see you in 6 months, maybe? We don't know. And it's the same thing. It's the same thing.
I'm still refactoring.
Exactly. So, you know, there's this time next year, it's gonna have like going way ahead again. It's not a linear like growth increase here. It is exponential.
Okay.
What would be your one advice to people who are, because you know, I'm working with different customers and I see some people, and that gives me the whole spectrum as well. But some companies completely ban it. How can you know, go to your boss and say like, hey, let's try something before we, not talking even, you know, full automation, because that's especially on the enterprise, that's a bit more complicated. You need to get this, but to start something, you know, to get a foot into the door.
So I talked to a person in London about this 2 weeks ago, and he was like, hey, how do I even get started with this? How would I bring an agent into my system? I said, do you get bug reports? The person said, yeah, they do. I said, when you look at a bug report, do you know generally in the system where the bug report is? He was like, yeah. I was like, why did you ask Claude at the same time as you're analyzing the bug report to also analyze the bug report and build confidence in the system that way? He's like, what do you mean? I said, so if you know how you're going to fix a bug, Claude comes back to you and says, the bug is here. You know, if it comes back and says it's in the same area, it is due to the same issue, it is due to the same concern. Then you can show other people that they can help their process by moving and analyzing bugs. It's not writing code. Okay, because that's a whole trust issue of how it writes code and what it does. You can 100% help you analyze problems and reports that are coming in to help you understand where problems are. Once you build that trust in it, and once other people in the organization build that trust in it, if you take that to your CTO and say, hey, look, I'm able to diagnose bugs 50% faster by using this agent, it's not writing code. All it is it's helping me understand where the bug fix is. Then they're going to pick it up for sure. They're going to understand that this is actually something that can help their organization, not hinder their organization. And that's a really good place to start. You can say, analyze my web app, find me the 5 places that have accessibility issues.
Yeah.
That is going to help our users like have contrast gradients to be able to like see things better. If it comes back, you know, you're actually doing something better in the world just by asking an agent to analyze it. You're not asking it to fix it, analyze it. And that analyzing plan loop is so useful to be able to get started with.
But Paul, I asked the agent to look at errors in my API, and it comes back like, here's the top 8, and then it asks, right, do you want me to fix this?
I mean, a logical next step is going to be, why would I fix it myself if the agent can fix it, right?
It's like,
the fact that it asked you is a really good step. because it analyzed it and it asked you for permission. And probably in larger orgs at this moment in time, they say no.
Yeah.
But you'll say, write me a detailed plan of how I can fix it.
Yeah.
Great. But then it'll actually be in 6 months' time. Actually, you know what? Maybe you just fix it and I'll review the output of what the fix is. And I think that's how the gradual snowball is going to pick up in some of these larger orgs.
I can see it much faster in the private sector than in the public sector. Public sector, it's hard.
Yeah, I mean, they're slower to pick up a lot of technologies anyway, right? Like, I mean, go back 10 years and bring in an infrastructure as code tool into the public sector. You had a similar sort of level of,
But Paul, how adapted is this? How many companies are using it? So you're seeing this big, I think I heard maybe 3 or 4 companies that are using the same AI tool to start building code. But
honestly, I think we're seeing way more now. Like 6 months ago, we were hearing horror stories about AI and what AI did in our organization. Now we're genuinely hearing success stories. There's actually going to be a conference in Stockholm, an agentic conf in Stockholm by a guy called Robert Weston. And his is because of the hype and because of like the success, and he's bringing in speakers from all over.
Are you coming, Paul?
I will be there. I'm not going to be speaking, but I was actually speaking to him about it. That's in end of April.
And Robert is a good friend. I met him yesterday.
There you go.
A beer, like that's
there you go. So and like that's because they're like companies are having real success at this moment in time with these technologies and these like ways of writing apps. So that's what we're going to see more and more and more of that going forward. And then there's another one that's in Hamburg, Agentic Conf Hamburg, which is a similar vein at the end of March. And that's also going to be the same thing. So there's a lot of celebration of success now rather than getting together and commiserating over like alcohol like it was 6 months ago. But it's like, I think in a couple of months' time, we're going to see even more success.
Okay, people, we come to 50 minute. Did kind of good, Paul, right? It wasn't that long, right?
No, I mean, I think this was a great discussion because each of you bring like different like thoughts and concerns. Lena, you bring like the consultancy, like how you can bring that into other places, and Matthias, you have like in the ops world as well as like different people bring different like ways of thinking about this. So it's always interesting to see how AI is going to implement.
Sounds good. And with that, I will going to press stop here. Thanks for tuning in.
Thank you.
Thanks.
You have been listened to DevSecOps Talks with Matthias, Andre, and Paulina. For notes and information, please visit devsecops.fm. Thanks for tuning in.